All right, I'm going to show a quick example of the manufacturing CNC workflow with a couple little bits to walk you through the basic process. And so I'm going to assume we're going to be using 3/4 inch stock. And so I'm going to design something that's 2 1/4 inches thick with the idea that I'm going to slice it into 3 bits and then glue them back together at the end. And I'm just going to do more or less a donut because why not? So let's make it 10 inches-ish. Well, exactly, actually. And then we'll do, I don't know if that I hit the center there. Let's try it again. C for circle. Do 5 inches. Lovely. And then I just want this to be 2.25 inches tall. And maybe let's fill at the top a good amount. Cool. And let's chamfer this bottom a little bit. Make some kind of an interesting little shape, almost ice cream cone-ish shape. Um, cool, weird, interesting, asymmetrical, and not something that we could do coming from one side of the material with the CNC, obviously, because we can't do undercuts, right? We can only plunge down. So there's no way we could do this if we were just doing it from one side. And this is 3 times thicker than what our normal thickness of our stock is, 3/4 inch. All right, cool. So what if I want to do something like this and I want to break it up? The first thing I would do is construct offset planes at increments of the thickness of my material. So I know it's 3/4 inch material. That's what I'm going to use. So we'll have an offset plane at 3/4 of an inch, and then we'll construct another offset plane. And this time I can select the previous offset plane and again offset it 3/4 of an inch. And now we expect to see if we look directly right at it that we have planes cutting this basically perfectly into 3/4 inch sections, which looks to be right. So I trust my math. And so I'm just going to simply split this body with these two planes as splitting tools. And as we remember, it can be sometimes difficult to select this plane, right? Right now I'm highlighting this donut plane, but if I hold down my mouse when I click, I get this little thing and I can move through the things that I had clicked on and select what I want. So now we can see from the side here that I'm going to cut it into three with these two splitting tool planes selected and that body selected. Okay. And if I look at my bodies, we can see we have 1, 2, 3, and they're all 3/4 inches thick. So I've been a smart person. I have made a design that is exactly an increment of my stock thickness for the sake of this demo, and we've cut it into three. And now we need to make it CNCable. So for me, I think, I like to just create a sketch, um, just for my own sanity, really, on the main plane. So we're looking up from the bottom. I'm going to switch back to looking top down. And just to like keep sanity, I'm just going to like make this a 4 foot by 8 foot sheet of plywood because that's what we know we want. And as we talked about quite a bit in class, for the sake of axes, this 8 foot, this is our bottom, and this is how we should think about our 4 foot by 8 foot sheet. This is our origin over here. 8 feet is in the x-axis. That's what we want for our machine. So I'm just going to do that to make it easy for me to sort of think about our stock. So great. Awesome. Okay, so now we have to get these parts and arrange them onto this stock. And luckily, in our design tab, we have the ability to arrange. But if we do that, we cannot select these things because they need to be components. Oops, our hygiene wasn't good. Let's go back. Let's create component from body, create component from body, create component from body. Wonderful. Now we should be able to arrange them. Um, component, let's select our envelope first. Let's select our objects. One, two, three. Let's take a look. All right. We got three things. They are in our envelope. Wonderful. Um, cool. We're basically ready to go. That may be problematic. Let's think about that. Can we edit this arrangement such that um, we can move them slightly? 2D true shape solver, envelopes, placement clearance. Let's maybe give it, we know our bit is a quarter of an inch. Maybe let's give it three-quarters of an inch clearance so that maybe more than that. Let's give it an inch clearance just so that we feel like um, if we're cutting these out, we want some stock in between them to hold the tabs and hold them in place. So maybe at least an inch clearance on each side. Let's see, did that do anything? It doesn't look like it did. Maybe it did. Uh, clear, clear, clear selection. Let's go from here to here. Let's see, 7 millimeters. So that does not seem to be successful at making that an inch. Uh, just look again. You would love for this. Maybe that 1 inch is only around the outside. Yeah, so this might be what we actually need. 1 inch object spacing. There we go. 1 inch frame width. Okay, that looks quite a bit better. Look at that. Wonderful. So now we have our things. They are spaced a little bit, and they're all oriented properly, right? So, we could have in this arrange changed the direction of any of them, but we want, you can see that makes one face kind of the wrong way so that we couldn't possibly CNC it, but it has intelligently given us our weird features face up and sort of interestingly floated them up off of the zero plane, but they're all in one plane. So I actually don't think that should be too big of a problem for us. So we do want to check that they're all in one plane. And um, yeah, we want to make sure that their clearances are good. Okay, we're ready to go. So let's go to the manufacturer tab. And the first and most challenging piece will be creating our setup. So the first thing we want to do is check that our unit is in inches because um, this is what shopbot is expecting, some inches units. So that's great. So we should hopefully be in the milling tab by default. Make sure that you're in the milling tab. And now we're going to do a setup. I'm going to click this first button, a setup. And we're going to go through this in quite a bit of detail because this is the main thing for us to get right. So first we'll select a machine. I'm just going to select the generic Autodesk machine. So if this doesn't pop up for you as recent, clear filters is always a useful button up here. You can click in the Fusion library. You can maybe search for generic um, and look for one that looks like our shopbot, which is like a kind of a gantry system. So here we go. Generic three-axis router. Great. Perfect. That's all we need. So we'll select that and download the model if it asks us to. Wonderful. So that will be our machine. That's really not that important. There it is. We're going to be milling, so that's correct. Now we need our work coordinate system. And again, I drew out this line. I want to reiterate, this is the X, this long axis is the X, the 4-foot axis is the Y. So that looks like it is oriented correctly. So that is exciting. Um, and we will just go ahead and leave it as model orientation because it's correct. We see the X that direction, the Y that direction, and the Z direction that direction. Otherwise, I'd play with this until it lined up the way that I was hoping. But for now, we're looking good. Okay, the origin. Okay, I'm going to check the model box point origin. So let's see. Now, for now, it is selecting all of these different parts that we have in this model. All of the bodies are embedded in this piece of yellow. And the yellow is our stock. So the stock is changing size to uh, capture the models. But we don't want this part, these bodies, as part of our model. So I'm going to go ahead and click select on the model, and I'm going to only select the ones that I want. So now I'm only selecting these three parts that are going to be part of my CNC operation for this. And now I will go back and deal with this origin point. So you can see the origin is relative to my model box right now, which is the same as my stock, basically. But I'm going to pick a point, which is the lower left-hand corner here, as my 0, 0, 0. Actually, let's pick the top left hand, because we with the CNC machine, right? We're going to be sort of uh, Z probing down and setting our 0 point to the top, the top uh, bottom left corner. You know what I mean? So like it's the top of the sheet in the Z plane is where our 0 should be because we're probing from the top, and we're going to be working referenced off of this probe point. So let's go ahead and set it there. Awesome. We have our model. We have that. I'm not going to worry about fixturing. We're going to kind of assume you're going to fixture this intelligently out of the way of the thing, and we don't need to model it. Now let's move to our stock tab. So our stock is going to be a fixed stock. And we know that, again, the X is going to be our 8 feet. So I could literally type in 8 feet. Um, let's see if it'll do that. 8 feet. Okay, cool. The depth is going to be 4 feet. And the height, as we already discussed, should be 3/4 of an inch. Okay, and now we need to not have our thing be cut right in the middle. Why would you do that? That feels weird. So let's position this to be offset in the negative X direction, maybe 1 inch from our model. And then in the negative Y direction, again, maybe 1 inch from our model. And you'll notice that even though I switched to offset from -X and offset from -Y, it kept the stock in the same place and just populated what the offset was. So we need to do that 1 inch to make that work. And then let's look at our Z positioning and make sure that we're in line with our stock. So I don't see our little yellow stock. Where did it go? Okay, our stock has no Z depth right now, it looks like. If we just snap to the front, and it's giving us something happened as we were moving things around. So let's just fix that and put it back to 3/4 of an inch, which it still kind of doesn't like. It's not liking that symbol, but okay, 3/4 of an inch. Did it take it? No. Let's try a 0.75. Ah, and I hit enter, which I shouldn't have done. So I'm going to go back and edit the setup and take us right back to where we were. All right, 0.75 inches. Okay, great. And here it has model position center, which I'm actually kind of surprised that it seems to be lining up perfectly with our stock, because in my mind, that model position should actually have been offset 0, um, which seems to be doing the same thing. So maybe it has just centered both. In my mind, offsetting 0 feels like a more correct thing to do. But all we really care about is when we're looking at it from the front, we see that we're perfectly aligned with our stock here. And so now it's looking right. So when what we have done is we've just picked our machine. We have set our axis point, to be this 0, 0 point in our stock. Well, 0, 0 sort of like relative to our model at the top, right? In the correct corner. And then we've created our stock, which looks like a 4x8 sheet. And we've moved the stock so that it's positioned correctly relative to our pieces here. So that's really good. Okay. Now we are going to, we're feeling good about our stock, part position. We will go ahead and line our stock up with this bench. And this little model floating over here is kind of annoying me right now. I don't know if there's anything I can really uh, do to, yeah, there we go. We'll just turn that off because that's kind of obnoxious. So we don't have to look at it. And we're going to take our fixture point, which will be, we'll take it from our stock box. How about that? And we'll take our stock box, our bottom left corner of our stock, and we'll attach it to the table in the top, uh, on the top of that corner itself. And so now it's looking like our sheet is lined up appropriately with this machine. Okay, this little fake machine that they have in here, this generic thing, is not the same size as our shopbot, which will perfectly fit our sheet. But all we're really doing is simulating. It doesn't matter that the machine isn't exactly right. What really matters is our coordinate system and that we've correctly done all those things with our stock. So at this stage, we have a setup. And what do we notice? We notice an XYZ point where the X is in the right direction, the long direction, and Y. We have our model. Everything is lined up. When we click front, we see everything is perfectly lined up. This is perfectly on the surface. We're looking really clean and good and referenced from our X, Y, Z point exactly the way we want. Okay, so now we have a setup. Now we have the ability to do some operations on this. And so there's going, much like with the Carvera, there's going to be a couple, we're just going to do two for this particular example. One is a 3D contour to deal with these curves and chamfers. And then one is a 2D contour to cut the part out with tabs. So first, let's select this 3D contour. And the first and potentially most confusing and difficult thing you're going to have to do is select your tool. So I'm going to click select. And if we click around here, we have our user libraries. If you're not seeing this, clear your filters. Clear your filters. We have user libraries. We have vendors. If we go to bits, cutting tools, we know our cutting tool is a 1/4 inch in diameter. And that's really all we care about here between these different 1/4 inch size tools. You see, this is a 1/4 inch. These are all 1/4 inch. It says right here, diameter 1/4 inch. So we'll just pick this top 1/4 inch tool. And that should probably do us just fine. Um, if you're down there and looking at the type of bit, maybe you pick the same type of bit, the same fluting. If you can line it up. I actually think this one might be the closest, but I'm not totally sure. But the sort of biggest thing is that we have this 1/4 inch bit correctly selected. And whenever we select one of these, you will see that we also have different cutting material we could select between with feeds and speeds that are suggested based off of that bit. So that's really nice. We can select that we're going to use wood or laminate. And if we're using something like OSB and we're not sure, maybe we see they're the same spindle speed. This one's a little bit slower feed rate. So let's just go with that one. We'll try to be a little gentler with our tool. And so that's the bit I'm going to pick, this bits, 1/4 inch bit, basically the first 1/4 inch bit. And I'm just going to choose that we're cutting into wood and plywood. And if I'm starting to dial this in, maybe I double check these 1/4 inch bits against the actual bit and try to pick the closest one and use those feeds and speeds. And then as I see my cuts, I might hand modify these feeds and speeds. So you'll see now that we have this tool, it's going to change our feeds and speeds, our plunge rates, etc., in order to match because we have this material. And you can go in and modify everything by hand when you generate your tool path. So great, we have that. Geometry, we can select our geometry. It's already selected these three things for us. You can see we have this fully curved surface. A little bit of that curve is left here. And then we have the chamfer. So I'm just going to go ahead and click OK. Once I've selected the tool, and we have, it has basically identified the curvy bits that it needs to cut, and it's created a tool path for us. And I guess this part maybe doesn't actually have a meaningful curve or a curve that's within tolerance. for what we're doing. So it ignored that. I mean, these tools tend to be pretty smart. And so we can see, we have our setup that we made. And then under that, we now have a cut, our tool path right here that we just generated. So you can go back in and change those parameters if you need. Say you need to dial in something a little bit, it didn't cut exactly right. You can go here and click edit and just modify those feeds and speeds. We can also simulate. And here you can just you can click play and you can see your little guy go around and cut through the tool. And I mean, you can see everything that you might want here. We could have the stock on if we wanted to watch it get cut away. It's a pretty nice visualization tool. And you should always visualize your cut to make sure it's going to do what you want. Right? So awesome. We already have one cut doing our circle passes here, our sort of curve passes, 3D shapes. Pretty epic, looking really cool. Okay, so there's that. The other type of cut, so the final cut that I'm going to make is a silhouette cut, and I'm going to do a 2D contour. It's already selected that tool for me, which is great. I don't have to worry about it. I'm going to go to my selection. Nothing is selected. And this time I'm going to I want to do silhouettes of these objects. I want the inside and outside silhouette. And I'm just going to click all three of them. Okay. And so now we have these little lines of where it will cut, which is exactly where we hope it will cut all the way through the material. But this cut is concerning because we're going to have this little bit floating, this bit floating, right? And we don't want them to bang around as the cuts are happening. So we need to add tabs to this. And that's nice and easy because we have it right here. So we can click that we want tabs, and you can see it has auto created a whole bunch of little tabs with a certain width or height. And we could just accept that. That sounds great. With a 2-inch tab distance, we could say 3 inches and it'll do it automatically. You can also you can click manual and you can add tabs yourself where you would like them. You know, um, so there's a lot of customizability here, but it's gonna make tabs for us. And then we're good to go. We'll click OK. Let's simulate. Okay, well, so it has simulated that the first cut has already happened. Maybe that first cut looks a little rough. We had some pretty intense passes there. Um, so we might want to go back and do a finishing pass before we do our actual final cutout. But here we go. We can see it cutting through the material, and you can see it's leaving tiny little bits of tab in the stock. And if we turn off our tool, or sorry, our stock, if we zoom in on the tool path, you can see that it lifts up just barely with each pass to leave these little tabs. So that's awesome. Looking good. And yeah, maybe, take a look at these different passes and their options, right? So you can see this, this describes what the pass is like. Here's the 3D contour. What does it say about it? This is a finishing or semi-finishing operation for steep areas. Here is a roughing operation, right? So quick, dirty. It's not going to leave us with a nice clean surface, right? Maybe we want this kind of a pass where it's actually working up and down the surface instead of going around and down into the surface, right? That will probably be a very nice finishing pass, a parallel finishing pass. So maybe after my contour pass, I actually decide to do a parallel finishing pass and put that in between these two passes here. So I can generate all these different passes. And so the final thing I need to do is actually create a file I can drop onto the CNC machine. And that is accomplished by right-clicking on this guy, clicking Generate NC Program. We need to select Post. And I have it here, the shopbot open SBP, but you may not. You may have to go into this little dialog box and search for shopbot, and then select shopbot open SBP and just stay OK. And then it will generate a file with this file name into this folder using inches. And if you click post, it has successfully created this program. 1001 shopbot. And you can drop that onto the shopbot and it will run. The thing that you should be wary about is your XYZ axis and making sure that you have correctly referenced. When you set things up, right, as we set it up here, if we look at our setup, right, our XYZ 0 point is here, right, is where we have set up our operations to target from. So that's what it is expecting, right, that you are going to sort of put your XYZ point potentially in a little bit in the stock, right? If this is actually representing our stock, we've moved our XYZ point an inch in on either side. We could put a screw in here to hold our stock down, and it's expecting the top to be zero, Z. So you want to make sure when you're setting up the shopbot that it is also set up with this exact same origin point, with the top of the material being your Z equals zero. And, it's almost inevitable that you will accidentally mess up the axes at some point and generate some commands that cause the shopbot to try to run away somewhere far away, and make some big sounds that you should turn it off, and stop it. But yeah, that is basically the entire workflow, from a part to what should be a file that you can drop onto the shopbot and get it to cut, for you. So, and once again, this is all in the manufacturing pane here. Um, we have our setup, and then we have our specific cuts. And we chose a 1/4 inch bit from BitBit, bitsbits.com, I think. And for that, we took the generic tool, the generic 3-axis CNC tool during our setup, but then we had to use the shopbot post processor when we generate our NC program here in order for this to work. But this is incredibly powerful. There are a ton of amazing machining operations that Fusion gives you access to. Some of them are very intelligent. And every one of them, basically for every one of these operations, there are a ton of things for you to take a look at and potentially dig into. I've just tried to highlight the high level ones. You basically are always going to need to choose your tool, which gives you feeds and speeds. And you're basically always going to need to pay special attention to the geometry that is being selected to be cut out with that tool. Um, uh, and we are using 3-axis machines, so that's nice and simple. Some of this other stuff, is just more tuning of some of these little things. But it's relatively straightforward, and I wish you all the best of luck, and I hope this video was helpful. All right, talk to you soon.